Hello guys, welcome to my YouTube channel. This is my beautiful channel and it is Dramani Online Maths. Please, if you know you have not subscribed, subscribe, share, and also like the video. In fact, like the video once you watch it. Some of you will just download it. You not even watch it from the YouTube. If you download it, I get nothing. Thank you very much. Um, we are the complex Fourier series. Small, we are moving. Theorem. Let's see this theorem. If f is a 2L periodic, piecewise smooth function, then its Fourier series has a complex form denoted by this. Okay, so this is the formula. Capital F, small f at x is given as this. Now, we need to find Cn. Once you get Cn, you just come back and substitute that. So the Cn, because it's 2L periodic, this time it's not just L by 2L, it's 1 over 2L. Integral of negative L to L, f at e to the power. Now look here. Here the e, the summation side, the e was to the power positive in pi x over L. Now the I is coming in because of the complex nature of it. But when it's coming here, or when it comes to this place and you are coming to integrate, here is negative, here is positive, here is negative. So you should take note. You shouldn't be confused with it. Now let's look at these definitions of e to the power in pi xl, the positive side and the negative side. In fact, when you look at the algebra, the polar side, when we are doing it, we look at these definitions there. So the e to the power in pi x over L is defined as this: cos n pi x over L plus I sine n pi x over L. And when it is negative, the only thing that changes is the minus here. This plus change towards negative. That's all. So you should take note of it. So when we are solving it and we come across this, we are going to define it this way. So you shouldn't be confused when we get to that place. Thank you. Now let's look at some examples. Okay, example. We have complete the complex Fourier series. So it's stated categorically. Complex Fourier series. Okay, if it is not stated, you can't use complex to do that. When they say complete the Fourier series, you go by the normal one. Complete the Fourier sine, you go by the Fourier sine. Complete the Fourier cos, you go by the Fourier cosine. When they say complete the complex Fourier series, you go by this one. So the first thing. So we said that this is given us, right, as n goes to 1 towards infinity, right? So this one is supposed to be negative infinity to infinity. So let me check. So please, I think from the beginning or the definition, it's supposed negative infinity to positive infinity. Okay. So my first explanation that I gave, please, this side should not be n, but rather negative infinity to positive infinity. Thank you very much for noting that. Cn e to the power I n pi x over L, right? So we need to find Cn, and we say Cn is given as 1 over 2 Lm, write the formula, the integral of negative pi to negative L to L. Then this side is the function given multiplied by e to the power negative I n pi x over L dx, right? This is the formula. So let's substitute. Cn is 1 over, our L is the pi, so we have 2 pi, integral of negative pi to pi. F at x is the function given. The function given is what? E to the power x. And this is multiplying by e to, this L is pi. So pi will cancel pi, leaving negative I n x dx. Is that okay? Now, the next thing to do is that when you remember or you move to our indices, indices says that one of the laws says that if the bases are the same, we add the powers or the exponents. So means that I'm going to have Cn equals 1 over 2 pi negative pi to pi e to the power x. So when you add this, that will be x minus I n x dx, right? X is common, so I can factorize it out. So what this means is that my Cn will be equals to 1 over 2 pi integral of negative pi to pi e to the power x. See, here I'm factorizing x out. So I'll have 1 minus I n dx. Now, this one is easy to integrate, okay? It's very, very easy. You know how to integrate. This one is no integration by part. You know how to integrate exponential functions in the term of this. So for you to integrate this, what you are going to do is that you are going to differentiate this. You are going to differentiate this. Is that you keep everything. Let me keep it first. You keep the whole function 1 minus I n times 1 over the power. So if I differentiate this way, let it 1 minus I n negative pi to pi. You see, when it is normal differentiation, it will be you keep the function times the differential, then you multiply by the differential of the power. And when it is integration, you keep the function, then you multiply by 1 over the differential of the power. That's how it is done. So for this one, what I'm going to do here is that let me conjugate this. Let's see. Let's conjugate this. If you conjugate this, this is 1 over 1 minus I n times 1 plus I n, all divided by 1 plus I n. So for conjugation, you realize I'm going to have 1 plus I n divided by 1 minus n squared. Sorry, here 2 will be plus. Is that okay? This is difference of 2 squares. So 1 times 1 is 1. Sorry, 1. Then negative I times negative I produce, when you multiply I by I, it produces negative 1. Is that okay? So because 1 is already negative, that negative will affect this. That makes it positive here. N times n is n squared. Okay. So let me clean this side. So after conjugation, this is why you have Cn equals 1 over 2 pi 1 plus In over 1 plus n squared. Then this side is going to be E. Now I want to put this one in, right? So if I put this one here, I'm going to have E pi bracket open 1 minus In minus, I'm putting this one there, E pi minus pi 1 minus In, like this. So this is what I'm going to have. So it means that my Cn is going to be, I hope you're okay with this one. This 1 plus In over 1 plus n squared is affecting the whole of this. So that's why I factorize it out. Then I will substitute the upper and the lower limit into it. Is that okay? All right. Let me multiply the pi through and see what you are going to get. 1 over 2 pi 1 plus In over 1 plus n squared. If I multiply through, I'm going to have e to the power pi minus e to the power I pi n. Is that okay? This is what you are going to get. Minus e to the power minus pi plus I pi n. This is what you are going to get. Let me clean this side. It's a little bit complex because it's a complex what? Fourier series. You're only looking for the Cn so that you can come and substitute. Now, with the same indices, since this one I can split it, right? So my Cn, you see, this place I can split it like this. So my Cn now becomes 1 over 2 pi 1 plus in over 1 plus n squared. Bracket open. Now this one, if I split it, become e to the power pi multiplied by e to the power negative pi n. E to the power negative I pi n, right? Then this side 2 becomes e to the power negative pi. Let me clean this side. E to the power negative e pi multiplied by e to the power positive I pi n. Is that okay? So this is how it will look like. It's going to look like this. I hope we are not confused about this. You see, I'm multiplying, so if I add them, I'll get back what I was having. Now, this one, I gave you the definition. E to the power negative I pi n is defined as cos. Remember, it's supposed to be cos n pi x over L, right? Because it's minus, so minus I sine n pi x over L. But this L here is the pi. So if I put pi here, you see this pi and this pi will go. And leaving nx. And that x again is a pi because when the limits that was given to us was negative pi, positive pi. So when you put the pi there, you see that it will still go. Is that okay? Good. So let's see that. So it's going to be I n pi n is going to be cos n pi minus I sine n pi. Please, you understand why I'm bringing pi again. You see, this L here is already a pi. Which pi are we talking about here? This L is a pi, so this pi will cancel, leaving nx. But you see, the limit that was given to us was also pi, negative pi. So that one is also x. So wherever you see that, you put that pi there. Is that okay? So the x will also be replaced by pi. Now, what it means is that my e to the power negative I pi n is going to be, you know that sine n pi will be 0 because n pi will give you negative 1 to the power n. Is that okay? So this is what you have. Now let's also look at e to the power I n pi. That is the positive side of it. So that is going to be cos, I'm going straight, n pi plus, you know, this one, because it is positive here, become plus I sine n pi. So what it means is that e to the power I n pi is also going to be, this one goes to 0, this one gives you negative 1 to the power n. So this one, the one with the negative and the one with the positive will all give you negative 1 to the power n, negative 1 to the power n. So let's see. You are going to substitute it here. So this is what you are going to get. Cn equals, I have my 1 over 2 pi here. So 1 over 2 pi. I have my 1 plus in over 1 plus n squared. 1 plus in over 1 plus n squared. Now I have my e to the power pi here. So that one is coming. E to the power pi. The whole of this is now negative 1 to the power n. Negative 1 to the power n. Minus I'm bringing it down here. E to the power negative pi. The whole of this is negative 1 to the power n. So this is what you are going to get. Let me clean this side so that it will be clear. So my Cn is equals to 1 over 2 pi. Look, 1 plus in over 1 plus n squared, right? 1 plus in over 1 plus n squared. Here, this one and that are the same, so I can factor in negative 1 to the power n out, leaving e to the power pi minus e to the power negative pi. You have something like this. Now, we can introduce something here. If I put 2 here, then I bring 2 here. I have not done anything to the question. These 2 will cancel it, go back to the normal. When you do this, this is what we call what? Sanch, right? So these 2 will cancel this one, leaving Cn equals 1 over pi, bracket open. Now, this negative 1 to the power n, let me bring it here. I can bring it here. You know that. So that here we left with 1 plus in over 1 plus n squared. And this one is what? Sanch pi. Is that okay? So this becomes our Cn. Is that okay? Now after getting Cn, you just go back here. Then where is it? Here, then you substitute. So my f, small f at x will be approximately to negative infinity to positive infinity. Cn, which is negative 1 to the power n divided by pi, bracket open 1 plus in, all divided by 1 plus n squared, sinus pi. So this, after this, remember there's e here. E to the power in. Now this pi will not come again because the L is also pi. In what? X. So this becomes our final answer to the question. Somebody may ask, why did I conjugate? You can decide not to conjugate it. You will get, that was 1 over 1 minus in. You will get it. No problem with that. Okay. Thank you very much for watching. Please subscribe for more.